Okay, so the next question that we have on the menu today is full of text, but nothing to be worried about. We have two transformers. Typically, this means electrical transformers, and between your house and a high voltage transmission lines that distributes power. Your house is the only one that's using the electric power. Okay, so maybe to draw a diagram to make this a little bit more clear, here we have a power plant. And it says we have two transformers. Another transformer. This is our house. Okay, so the first transformer that we have is a 1 to 29 transformer. Okay, and because of our usage, the current that exists in the primary of this transformer is 40.0 milliamps. So I primary is going to be 48 milliamps. Okay. And the secondary is connected to the primary of another step-down transformer, which has the ratio of 1 to 32. And this is somewhere near our house, up on a telephone pole, or I guess that could be a place where it is. And we know that we have 240 volts at our house. Okay, so we want to find out how much power is our house using. Of our house. Okay, and everything that was given to us in here in this or all of these like currents and voltages are all RMS. And RMS is cool because we know that the power equation P is equal to current of RMS current times RMS voltage. So I RMS times VRMS. Okay, so we know that VRMS is we are given this by the question. And this we need to solve for given the two transformers and original source current. Okay, so let's look at chill out one note. Okay, so let's take a look at how currents and transformer turns are related to each other. So transformer currents because it's really just like a fairly simple equation like this. So the IS or IP is equal to the NP over NS. Okay, P represents primary. Most of the time we'll use primary as like the input, and secondary, the S, is the output. Okay, so if we want the secondary as a function of the primary, we know that IS is equal to IP NP over NS. And we know that if we know that this is the case, we know that like we're at the very end, we're going to be observing a secondary current, right? That's going to be the output current. So this is our final P. Let's call that P house. Is going to be I secondary of the second transformer times the V that we were given. Okay, but we know that output from second transformer, the input to second transformer, to second controller, transformer, not controller, jeez, is the output of first transformer. Okay, so if we know that our first transformer is like this, so our let's call that IS1 is equal to IP1 NP over NS. So this is transformer 1. And this is all equal to I primary 2. Okay, so this is the input to transformer 2. And we know that the input to transformer 2 is related to the output of transformer 2. So IS2 is equal to IP2 times NP1 and S2 times NP2 over NS2. And we know that this is equal to this. So IS2, we can write this as IP1, which we are given, NP1 NS2 multiplied by this term right here, and P2 over NP1. So this is going to be what we need for IS2, which is exactly what we need for here. Okay, so let's bring these together. See how all this algebra, we can all put it together without even touching any of the real numbers. We can set up everything that we need, and then it's just a plug and play after we've done our algebra. Okay, so we know that our P house, the power as observed from our house, is going to be equal to IS2 times our V that we're given. And we know that IS2 is IP1, which we're given, NP1 over NS2. NS1. Geez, these are, oops, I kind of screwed up some of these notes here. Nothing to worry about if we can fix it. NS1, NS2. Whoopsie daisies. But we fixed it, so we all good. NP1 over NS1 times NP2 over NS2. Okay, now running through all of these calculations, let's sub in our numbers. Oh, I actually need to multiply this whole thing by V. Okay, so the P-house is equal to, what's IP1? So IP1 is the current that is observed from our, is the current observed originally from the power station. So that's 48 milliamps. 48, whoops, times 10 to the negative 3 amps. That's another way of saying milliamps. Multiplied by NP1 over NP2 and S1. So that was 29 over 1. So this is transformer 1. This is original current. Then we're going to have transformer 2, and that was 1 to 32, so that means it corresponds to 32 over 1. This is transformer 2. And multiplied by the voltage that we observe at the house, which is 240 volts. voltage at house. Okay, so we just got to run this through our calculator, and that will be all that we need to do. So let's run that real fast. 48 times 10 to the power of -3 times 29 divided by 1 times 32 divided by 1 times 240, and my result for this is P house is equal to 10690.56 watts. And originally in the question we were given 3 significant figures, so we should round this to 3 significant figures. So another way that we can write this is P house is equal to 10.7 kilowatts. Okay, kilo just you know, if you divide by 1,000, we can just add a kilo to make it a little bit easier to write. Okay, and we came to pretty much the same number here. It's just like a rounding thing and significant digits, but otherwise this would be how we find the power of the house, and this is our final answer. Big happy face. Very powerful power calculation. Okay, so we can mark this question as good. The above solution is good. Significant figures in final answer. Cool. Nice.